Okay, so 3.5, derivatives of trig functions. 6 that you need to know and 6 that you need to memorize. That's why I gave you those note cards, and I'm going to give you a second here to fill in those note cards. First two, the derivative of sine is cosine. All right, I'm not going to go through the proof on this. This is one you need to know. If I ask you what's the derivative of sine, you got to be able to tell me it's cosine. Just like 2 plus 2 is 4, you got to be able to say sine is cosine. Okay? Derivative of cosine is a negative sine. So those two plus these additional 4, take a second. Let's actually take a look at an example. What is the derivative if y equals x cosine of x? Nope. Nope. If you can do this one with just looking at it, that would be impressive. I don't even think I could do this one just looking at it. Okay, because what's going on here? What's between the x and the cosine? Multiplication. So how do we multiply two functions? How do we take the derivative of a product?
Didn't think of that.
Ah, that's why we're practicing. Product rule. Jacob, what is the product rule?
The product is that if you have, I'm not going to do it before, but basically if you have two functions together, the derivative is the derivative of the first times the second function. Once the first times the derivative.
Okay, so u v prime plus v u prime. Or you could do the derivative times the original. Yeah. Okay, so for this one, what is u? What would we choose for u on this one? X. What is v? Cosine of x. What is u prime? 1. What is v prime? Okay, correct. One little thing that I use to remember when they're negative and when they're not, if we go back to the original here, all the ones that start with C, cosine, cotangent, cosecant, are all negative. So I think of the C as in cold. So it's a cold temperature, it's a negative temperature. If that helps you, great. If it doesn't help you, don't worry about it. But that's how I always remember. If it starts with C, I think cold, and so it's going to be negative. All right, so product rule. We're going to have u, which is x, times v prime, which is a negative sine of x, plus v, which is cosine of x, times u prime, which is just 1. Okay? X times negative sine of x, I would like this written as negative x sine of x. Simply bring that negative all the way to the left. Okay? Plus cosine of x, and that's our final answer. So negative x sine of x plus cosine of x, we have to do the product rule. Okay, there's two functions that are being multiplied, so we have to use the product rule on this one. All right, and as simple as it sounds, making this little cheat up in the corner will help keep you organized, because as these get more and more complicated in terms of length, you need to stay organized, because it's very easy to mess up a sign, S-I-G-N, a sign if it's positive or negative. Okay, if you're not keeping yourself organized, you're going to mess up the entire problem. So there's easy mistakes that can be made that we want to avoid. Okay, so negative x sine of x plus cosine of x, we're done. That is the derivative. Okay, let's do another one.
I don't like it.
Spoiler, this class gets harder as we progress through the year.
Yeah.
But when I say harder, though, we just get into more advanced problems. The process is the same, okay? And we start from foundation, and then we just continue to build up and build up and build up, okay? So as long as we can do the easy stuff, the hard stuff starts to fall into place anyway. It just takes a little bit more time to do it, but it's really not anything that we cannot do. All right, so we don't have a product going on. What do we have? Quotient rule, baby. So we have to use quotient rule. So ddx of, if we used our u's and v's, what is quotient rule in terms of u and v? So low derivative of the high minus high derivative of the low all over low squared. All right, so let's make a little key here for u and v. What would be my u in this problem? Cosine of x. And then my v is 1 minus sine of x. And I'm not just writing this stuff up here so that as I'm teaching it, this is how I work through problems as well. I always write down, or 99% of the time, I always write down product rule and I always write down quotient rule so that I can stay organized. So then I'm just filling in as I go through the problem. Okay, because you do not want to make those little mistakes. So u prime, what is u prime? Negative sine of x. What is v prime? Negative cosine of x, because I was at negative sine. Derivative of sine is cosine, so negative sine derivative would be a negative cosine. Or you can think of it as 0 minus sine of x, derivative of sine of x, so 0 minus cosine of x. So now to fill in, so my derivative piece now, I'm going to have v, which is 1 minus sine of x, times u prime, which is a negative sine of x, minus u, which is cosine of x. V prime is negative cosine of x, all over v squared, which is 1 minus sine of x squared. Now we can work to do some simplification. I have a binomial, 1 minus sine of x times negative sine of x. So I'm going to distribute that to each term. So I have negative sine of x. What is negative sine of x times negative sine of x? Positive or negative? Positive. So this would be plus sine squared of x. Okay, and so I have a negative cosine of x times negative cosine of x. So this would be plus cosine squared of x, all divided by 1 minus sine of x squared. Lena. Because it's really, because this, if I can think of this as a negative 1. Okay. So this is really negative, or you could think of it as these being multiplied as negative, but I'm subtracting the negative, so it's addition. Okay. Does anything pop out from the numerator that we can simplify? So what? I don't know. Jacob, do you got it?
I have a feeling that I remember, so I can't say that.
Correct. This piece right here, sine squared of x, okay? And I will explain this to help you remember, okay? There's only a few times that trig identities come into play in this class, okay? This is one, though, that you should know, okay? Sine squared of x plus cosine squared of x is 1, And this goes back to the unit circle. If I were to think of my unit circle, this is called the Pythagorean identity. Okay, sine squared of x plus cosine squared of x is 1. Okay, so if I were to make a triangle here in my unit circle, I know that my hypotenuse is 1. I know my x is represented by cosine, and my y is represented by sine. Pythagorean theorem tells me that it's going to be cosine squared plus sine squared is going to be equal to 1. Okay, that's called the Pythagorean identity. So sine squared plus cosine squared equals 1. Okay, so we can relate it back to the unit circle. Cosine is the x value, sine is the y value. A squared plus b squared equals c squared. Okay, so sine squared plus cosine squared does equal 1. So we have negative sine of x plus 1, all divided by 1 minus sine of x squared. Whoa, whoa, whoa. What did you just say, Zach? Okay, there we go. I like that better. Thank you, Hunter. 1 minus sine of x, 1 minus sine of x times 1 minus sine of x. This goes to a useful form of 1. So my final answer is 1 over 1 minus sine of x. That is the derivative of cosine of x divided by 1 minus sine of x. So you can see there's a lot of spots to make a mistake in terms of your sign, S-I-G-N, mixing up your signs, not doing your derivatives correctly. So just making a quick roadmap that I have up here in blue, what the quotient rule is, what my U is, what my U prime is, what my V is, what my V prime is. Keeping that all organized and just following through with the process, you can get to that final answer. Okay, let's do another one. What's the problem? I got 3 more. I got 3 more examples. Yeah, exactly. We have 15 minutes left, so why would we stop now? Yeah, you're fine. All right, here we go. Example 3. A weight is hanging from a spring, and it bobs up and down with position function. S equals 3 sine of t. So they're telling me it's position. All right, I could have written this as S of t equals 3 sine of t. Same thing. Okay, they told me it's my position function. What is the velocity function? Easy enough. So my 3 stays because it's constant multiple. Derivative of sine is cosine. So it's 3 cosine of t. What is the acceleration function? Okay, so this would be 3 times the derivative of cosine is a negative sine. So negative sine of t. And I want you to write this with the negative out front. So negative 3 sine of t. What's the what? Okay, I put these slides online too. Relax. Okay, so, but again, we know. Okay, so we know to take the derivative of each goes from position to velocity to acceleration. Okay? All right, so jerk. Jerk, again, is derivative of acceleration. I want to talk about notation here. Okay? Jerk is J of t. dA dt, we know this is the same as A prime. Okay, so the derivative of acceleration is jerk. Now let's give it to you in primes as well. So second derivative, we have the notation of d squared v and then dt squared. Okay, because if I were to take the derivative, oops, go back. The derivative with respect to t of s, we'll say s of t, we'll go ds dt. If I were to take the derivative of my position, I end up with d squared. So that's where that squared is coming from on the d. Okay, so my numerator is d ds, so it's d squared. But in this case, it's going to be v. d dt, it should be like this, but they simply just put the 2 on the t. So that's where that notation is coming from. Brady.
So if jerk is just a J, what is bounce?
I don't know. I don't know. Okay. All right, we got stuff to cover. So this notation simply means instead of the prime, so s triple prime of t, we can write it as d cubed s divided by dt cubed. So that's why in the numerator, the exponent is on the d. The denominator, the exponent should be on both, but they just write it on the t, but really it should be in parentheses, and we'd go from there. Okay? Okay, and again, jerk is just the rate at which acceleration is changing. Okay. This one, y prime. What is y prime if y is secant of x? Good. Secant x, tangent of x. Look at that. You guys are on top of it. Okay. So what is d squared y all over dx squared? Okay. I would say second derivative. You would never say it as d squared y dx squared. We just say, what is second derivative?
So now you have to do the whole
Product rule. Okay. So this is a product. Okay. So my u is secant of x. My v is tangent of x. Okay, stay with me. We got this one. We got one more. Okay. So secant of x, derivative is secant of x, tangent of x. Derivative of tangent of x is secant squared of x. So my second derivative, again, it's uv prime plus vu prime. So I would have secant of x, secant squared of x, plus tangent of x, secant of x, tangent of x. Okay, so what is secant of x times secant of x? Or I'm sorry, secant of x times secant squared of x. Okay, tangent of x times secant of x, tangent of x.
Say that until we go on third. Can we even do it? We can, but he's gonna make us. I don't know.
Okay, so final answer, our second derivative. And again, make sure you do not drop the x's. Okay, every year, at least one person makes a mistake where they leave out an x, where they write tangent of parentheses secant of x, tangent of x. Do not leave out an x.
One more.
I got this.
Only one more.
This is it. Okay, you do this one. Okay?
You got one. Oh, come on. Come on.
Hold on. Okay. Zach, hold on. Say again, Jonathan.
Oh, it's just one. Never mind.
Got it? Okay, you do cosine of x divided by 1 plus cosine of x. Okay, so did we end up with negative sine of x divided by 1 plus cosine of x squared? Okay.
It was the second to last one.